I pointed out in the before that the one key feature of FutureGrid is an on-ramp to other systems. And if you think about how FutureGrid supports other systems, well, it can do the education and training for everything. We're sort of doing that already. After you've been trained on how to do something, either using FutureGrid itself or just a particular, using Hadoop or using MPI, then you can use your final follow-up work on FutureGrid. It's a test environment. You can download an appliance with this technology to your local machine and run VirtualBox, or you can actually jump to a chosen production system using the cloud bursting capability of something like Cloud Mesh to access your production system. So Cloud Mesh is aimed at similar goals to OpenStack Horizon, but is aimed at multiple federated systems, not just at OpenStack and not just as a single cloud. It's built on our dynamic provisioning software, Rain, and it uses Python tools to implement its requirements. It uses something we'll discuss a little more, namely the templated image. That's an image defined by specified, not by logical capabilities, not by bits and bytes. And once you have a templated image, then it's a lot easier to retarget it because you don't actually edit the bits and bytes. You just take the same specification and generate it appropriately for the different environments, which could include Amazon, Azure, Google Compute Engine, Eucalyptus, OpenStack, ... or even just bare metal, HPC. Then Cloud Mesh provisions the complete system, and including not just a single image, but maybe you want a total virtual cluster, and it will deploy the full software you need. It will also include security issues, which we'll discuss, and it will integrate with our metrics package, which is built with the Exceed technology auditing service tasks, which is non-trivial because VMs have different metrics from HPC systems, and so to build a package that interfaces with HPC and so to interfaces with Exceed is non-trivial. This is the architecture of the next step in FutureGrid. We have here network as a service, infrastructure as a service, with mics and GPUs and networks and sensors included. So we have IaaS provisioning, giving you a virtual cluster, which is then delivered to you at the platform as a service level where you run Hadoop or MPI or what have you on it. So this is the software-defined distributed systems as a service here. That entire distributed system is monitored, has security, and then on the top of this we have what we discussed, the experiment management framework, allowing you to capture all the metadata that defines this experiment and reproduce that experiment on demand at any time. So that's the general model for reproducible computing testbed as a service. Here's a summary of the differences between what we are now and what we expect to be. The original FutureGrid was grid cloud and HPC. Grids are getting less important, but big data is rising in importance, so that's a change from FutureGrid I to FutureGrid II. Previously, we built experiments, or we do now build experiments for projects. Now we want to do repeatable, reusable experiments. Here we have fixed resources in education, but we want to allow one to use either Amazon or FutureGrid or appliances, depending on the particular educational needs. We want to move for application people to these templated appliances, specify the applications so one can span resources. That was the goal of Cloud Mesh. So that's the difference between FutureGrid I and II, the addition of Cloud Mesh-like capability in templated appliances. The provisioning model as network as a service, they'll give you computing testbed as a service and has 4 layers, not 3 layers. The configuration is relatively static currently. We want to make it totally software defined. We want to have federation, not a fixed system. Um, we want to not only have our current support model of actual support people, but actually have the community involved to get scaling. Uh, we want, instead of having a fixed set of clusters, which I went through for the current FutureGrid, we want to have software-defined systems and federation as the hardware model. We want to take out various dependencies like MOAB and XCAD and replace them with open source systems, which we believe you can do. Like MOAB can probably be replaced by Slurm, and XCAD can certainly be replaced by alternative capabilities, which we've essentially already developed. And we want to go from the current private distributed cloud that is FutureGrid to a mix of public and private distributed clouds with many administrative domains, which is the federated model to allow FutureGrid II to have a rich enough set of capabilities. Now we come to a discussion of security. So security is critical in FutureGrid because FutureGrid is running test software. And we do not have the security of knowing that we have a very robust, well-tested, basic piece of software. So we look at the security issues in FutureGrid. This slide here comes from the overview, and it points out that we would love more security projects for FutureGrid. So do your experimentation on FutureGrid, please, your cybersecurity experts. And if we look at the areas where FutureGrid has security issues, the first area is authentication and authorization. And the main problem there is it's just different. It's not that it's particularly harder than other systems, but as we have to build it around whatever Eucalyptus or OpenStack supports, that's not the same thing as Exceed supports, and so that means we can't, for instance, immediately have a common model between Exceed and FutureGrid. Further, the open source software keeps changing, and then that's good actually because it keeps getting better. And we need to isolate users from these changes. So that's an important goal of FutureGrid. We have to make certain that various glitches in the open source software, like non-secure default choices, are removed. And we're very pleased with OpenStack Grizzly, but we have to rework the access control mechanisms. And this will actually help us because the new model in OpenStack Grizzly is more similar to that in Amazon, Google, and Azure. The way we do our own system at the moment, which is what we integrate these new systems as they come along, we use LDAP, which links the portal and the virtual machine managers, and that LDAP servers synchronize via the AMI to the Exceed capabilities. So we can get the Exceed credentials to be recognized by FutureGrid. The other major area actually is the software that people are running secure, which is therefore the security of images. That's particularly sensitive if those images are dynamically provisioned. And so that means we need to do a lot of special checks before running dynamically provisioned images, especially if they're running on bare metal. And we will only run on bare metal when we've gone through a set of tests which makes certain the basic some basic issues are addressed, that we remove root access, we test that the software has its latest versions with patches, and we specify which users can use the software so not everybody can use it. And we do not store SSH keys in the image. Rather, we just call the identity service. So only users certified by the identity service can use these images. So we look at FutureGrid security model. The users are vetted twice. When you come into the portal, you're checked to see if you are real person, so people do not automatically get portal accounts. We have to verify that they come from a site that could use FutureGrid, so a research environment of some sort. And when they get through that step, we also double check them when they propose a project, then the proposals check again. And we have found this actually surprisingly easy and successful, and we think that maybe other systems should probably follow us in this fashion. And so we do not get spammers and actually logged into our system, even to our portal, which means we can have wikis and things like that updated by our users in this relatively safe fashion.